Hello! Today I am going to talk with you about descriptive geometry. The subject of descriptive geometry is the theoretical basis of the drawing. Descriptive geometry is an engineering discipline. The subject of descriptive geometry studies different things. For example, ways of constructing images of volume objects on a plane and ways of solving problems of a geometric nature based on the images of the shape on the plane. The source data should be presented as two independent projections. In most problems, the algorithms uses two orthogonal projections on the mutually perpendicular planes. Methods of descriptive geometry are used in the design of complex surfaces in the aviation industry as well as in architecture. Descriptive geometry also plays an important role in other disciplines. In addition, descriptive geometry allows a person to develop a spatial imagination skills without which engineering creativity is impossible. Images constructed according to the rules of descriptive geometry allow you to visualize the shape of the objects and their location in space, determine their dimensions and explore the geometric properties of the object. The rules for constructing images that are studied in the descriptive geometry are based on the projection method. Discussion of the projection method begins with the construction of the point projection, because when constructing an image of any shape of an object, this shape is considered as a set of points that formed the object. The main tasks of descriptive geometry are the next. First of all, study and development of methods for projecting geometric objects on a plane. Second, study of geometric transformations and their properties. The third, development of the methods for solving their dimensional geometric problems on flat image. And the last one, development of conditions and requirements that ensure the reversibility of the product and the quality of the product. That's the subject, descriptive geometry. Now let us discuss with you the method of projection. Images on the plane are obtained by projections. The projection apparatus is shown on our first drawing. The object of projection is point A. Through point A passeth the projection ray I with direction to the picture plane, called the projection plane. This plane is denoted as plane pi. It is the Greek letter. The point of intersection of the projecting ray with the projection plane is called the point projection. The point projection designation must contain the index of the projection plane. For example, when we are projecting to the plane with the letter pi n, the projection of the point will be denoted like AN. And now let us talk about the types of projection. There are two types of projection, central and parallel. What's the difference between central and parallel projection? In the first case, central projection, the source of ray, point S, is located on some distance from the projection plane. In the second case, parallel projection, the source of rays is located at infinity. It is placed so far from the projection point that we can say that our rays are parallel. Let some plane be given in space. You can see this example on our drawing. Let's denote it by the letter A small. We have a plane denoted with letter A small. Let's call this plane the projection plane. We have a point S that does not lie in this plane. Let's call this point the projection center. To project any point A located in space on the plane denoted with the small letter A, you need to draw a straight line through the projection center S and point A. This line is called projecting ray. We need to construct this line until the intersection of this line with the plane A at point A1. Point A1 is called the central projection of the point A. This picture shows us the image of 3 points that form a triangle. Through each point A, B, and C, we should draw rays from point S. All these points are projected on the plane denoted with the letter A small with the help of these rays, like it is shown on our drawing. On the plane A, we have obtained the central projection of the triangle ABC. But it is not necessary to project all the points of the figure to construct a shape of this figure. The projection of a straight line is determined by the projections of 2 points. And you know the rule that only one straight line can be drawn through 2 points. The projection of a polyhedron is defined by the projections of its vertices. That is the points corresponding to these vertices. But I must say that the method of central projection is complex and greatly distorts the shape of and sizes of the original object. So, the central projection method does not display the parallelism of straight lines and the relationship of segments. That's why, in practice, the method of parallel projection is more often used. The parallel projection method is a special case of the central projection method. In this case, we remove the point S to infinity from the plane on which we project the image. In this case, the projecting rays become almost parallel. You can see this example on our drawing. That's why the method is called the parallel projection method. Let's discuss this example. Let's take some shape in space, for example, triangle ABC. We project the triangle on the plane of projections denoted with small letter A. The direction of the projections is indicated by the arrow S. The projecting point to project point A on the plane denoted with the small letter A, draw a straight line through this point parallel to the direction S until it intersects with the projection plane A. On the plane A, we get points A1, and if we will construct the same parallel lines through points B and C on the plane, we will get points A1, B1, C1. These points are called parallel projections of points A, B, C. Now we connect the points, and on the plane A, we get a parallel projection of the triangle ABC. To perform a parallel projection, you need to find out the basic properties of these projections. First of all, each point and line in space has a single projection. The second, projection of a point is a point. The third, projection of a straight line is a line. The fourth, if a point in space belongs to a line, then the projection of that point belongs to the projection of the line. This becomes clear if we separately project a line, like it is shown on our drawing. Then we project a point that is located on the line. The point is necessarily projected on the line. It cannot be located anywhere other than on the line. The fifth property, projections of mutually perpendicular lines are mutually perpendicular. And the sixth property, of course, the projection of mutually parallel lines are mutually parallel. The next property, if the segment is divided by a point in some relation, then the projection of the segment is divided by the projection of the point in the same relations. Next property, to construct a projection of a straight line, it is enough to construct a projection of only 2 points of these lines. You know the rule that we can construct a line only passing only through the 2 points. So, to construct a projection of a straight line, it is enough to construct a projection of only 2 points of this line. Next property, if the line is parallel to the direction of the projection, then the projection of a straight line is a point. on this drawing, you can see this example. Our line, our segment AB is parallel to the direction of the projection. And it means that on the projection plane, it is denoted with letter A, we get only a point. And our last property, a straight line segment parallel to the projection plane is projected on this plane in full size. On this drawing, you can see this example. As you can see, many properties of parallel projections are individual. However, the most commonly used method of parallel projection is the method in which the projection direction from point S is perpendicular to the projection plane. On this drawing, the projection direction is not perpendicular. We have some angle, free angle. And the most usually used method is the method when the projection direction from the point S is perpendicular to the projection plane. This projection makes the construction of the drawing easier. This method is called rectangular projection.